Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. Okay, so in this video, I'd like to share with all of you on how to solve a few questions from the question that you might find it in your tutorial book for topic 5. Okay, so without wasting so much time, we look at the first one here. I choose question number 4. So you may also refer this in page. Okay, from your tutorial book, your tutorial book, turn to page 66. Okay, so we call the PSP question of function and graph. Okay, so let's take a look at the first one here. Okay, so then Gx equal to cube root of x and hx equal to 1 over x plus 1 cube. Okay, so to find that we got to determine the G inverse and also H inverse. In this case, let's change this into term of y. Y equal to x to the power of 1 over 3. So we got powered with 3 on the left side and also on the right side. Then x equal to y cube. So means that here the G inverse equal to x cube. Okay, and then turn the h into y equal to 1 over x plus 1 cube. So cross multiply, change the position here where x plus 1 cube equal to 1 over y, and then we go multiply here or come up with a cube root and also cube root here. So then x plus 1 equal to 1 over cube root of y, and then x equal to 1 over cube root of y minus 1. So means that here h inverse of this function equal to 1 over cube root of x minus 1. And state the domain and range for each of the inverse function. Okay. We may use this formula where the domain of f equal to the range of f inverse and the range of f equal to domain of f inverse. Okay, in this case, domain and range for both of these, domain of G inverse equal to the range of G, and the range of G inverse equal to the domain of G. Okay, so domain of G inverse. Let's find it now using the function of G and then the domain here. The domain of G equal to positive to negative infinity. Domain of G is all real numbers, so it's also the range of G here, which is all real numbers. And then we call the domain of G inverse. For this case, this is G inverse of x equal to x cubed, so that the domain is also all values of x. So it's all real numbers. Okay, so the domain of h equal to range of h inverse and range of h equal to the domain of h inverse. So domain of h, this is a function of hx. Okay, 1 over x plus 1 in bracket cube. So the denominator 1 over 0 is undefined. So then the denominator cannot be equal to 0. So in this case, x plus 1 cannot be equal to 0 or x cannot be equal to 1. So now the domain of H is also range of H inverse, which is all real numbers except for x equal to 1. So then union 1 to positive infinity. And then the range of H and also domain of H inverse. So this is the function of H inverse. H inverse of x equal to this one here. And the value of x inside the cube root cannot be equal to 0 because 1 over 0 is undefined. So in this case, it tells us that we got the range of H equal to all real numbers except when x equal to 0. Okay. And then the next question, function of f, g, and h, x equal to 2 plus x divided by x plus 1. Okay, so substitute the function of hx, f, g, hx equal to 1 over x plus 1 cube equal to 2 plus x divided by x plus 1. Substitute the whole function of this into an x of the function g, where x a function, okay, hx equal to 1 over x plus 1 cube, gx equal to cube root of x. So we can substitute into an x of this function of g. So f, which is cube root of 1 over x plus 1 cube equal to 2 plus x divided by x plus 1. Okay, so solve this separately here. 1 over x plus 1 cube. Cube root means that to the power of 1 over 3, where it is a 1 power of 1 over 3 divided by x plus 1 to the power of 3 and 1 over 3. This will straightly give you equal to 1. Okay, 1 over 3 times 3, and it is x plus 1. Okay, so f 1 over x plus 1 equal to 2 plus x divided by x plus 1. Okay, so now this one here, we are going to make some substitution here, where let u equal to 1 over x plus 1. So then x plus 1 equal to 1 over u, and x equal to 1 over u. Bring up here, become minus 1, or changes into term of u minus u. So 1 over u minus u. Okay, so now this term, okay, this 1 over x plus 1 is a u, and now x 1 minus u divided by u. This we are going to substitute here and also here. Okay, so then fu equal to 2 plus x 1 minus u divided by u divided by x 1 minus u divided by u plus 1. So this one change in the term of 2u divided by u plus 1 minus u divided by u divided by, and change in term of u over u. So then 1 minus u plus u divided by u. Okay. Okay, 2u plus 1 minus u. 2u minus u, u plus 1 divided by u, and bring this above here. Okay, so bring 1 over u, bring up here, become u. So then u divided by u equal to u plus 1. So it means that here the function of x that we're looking for here now is actually equal to fx equal to x plus 1. Okay. So now the function of fx equal to this. Okay, class. We write down the function of fx in the term of ax squared plus bx plus c. Ax squared plus bx plus c. So the function of fx for this function here is x squared minus 2x plus 1 plus 3. Then it is equal to x squared minus 2x plus 4. Okay, so this is a function of quadratic in the form of ax squared plus bx plus c, and this is a function of the quadratic function after being complete in the square. Okay, so here once we come up with the process of completing the square. Okay, so now determine the inverse function of f and sketch the graph f and its inverse on the same axis. And now to find the inverse, change the term of fx into y. Y equal to x minus 1 square plus 3. Then x minus 1 square equal to 3. Let's join up with the y here. It becomes y minus 3. So eliminate the square by come up with a square root sign here. And x minus 1 equal to square root of y minus 3, then x equal to square root of y minus 3 plus 1. Then f inverse equal to square root of x minus 3 plus 1. Okay, so then sketch the graph f and its inverse on the same axis. Function of f equal to x squared minus 2x plus 4, or according to the question here, you come up with x minus 1 squared plus 3. And its inverse equal to square root of x minus 3. Square root of x minus 3 plus 1. Okay, so now, y-axis and also x-axis. Okay, we sketch the line of y equal to an x. Okay, now from this equation, x minus 1 squared plus 3. Okay, first look at this one here. In the form of ax squared plus bx plus c, this is 1, where a equal to 1, which is greater than 0, the graph will smile something like this. Okay, and then from this equation, it tells us that when x equal to 1, y equal to 3, and this is the coordinate of minimum point. Okay, so now let's find out here now where x equal to 1, y equal to 3. Okay, so the graph will be something like this. Okay, x equal to 1, y equal to 3. So this is the graph with a minimum point of 1 and 3. And now class, please read for the question again. where x is element of real numbers and x greater than 1. Meaning, this graph is valid for x greater than 1. Meaning, it's just only half of the graph, right? So, the graph that we wanted from this function here, which is there you go. And let's erase the rest of it. So this is the graph of the function. Okay. The reason that I cut half of the graph of this, let's take a look at the question again. The function defined as this one here, x is a element of real numbers and x greater than 1, meaning the graph is only valid for x greater than 1. X greater than 1, from 1 here to the right side, all positive. Okay, now let's sketch the graph of inverse. Okay, the graph of inverse, so then when x equal to 1, bring up here as a y equal to 1, and also y3 bring up here as an x equal to 3. Okay, so just imagine that this line of y equal to an x as a mirror between the function and its inverse. Something like this. Nope. Okay, so this is a function of f and this is a function of f inverse. Okay, so the question wants us to find out, to sketch the graph f and inverse on the same axis. Okay, that's it. Next question. Okay, question 19. Given the function of fx, here show that f is a one-to-one function. Find the domain and range of f. Determine the inverse of function f. Okay, now. Okay, please please turn to page 69. Page 69. Okay, now. Function given there, fx equal to square root of 3 minus 2x. So that is a one-to-one function, so then square root of 3 minus 2x1 equal to square root of 3 minus 2x2. Okay, squared left and right. So come up with 3 minus 2x1 equal to 3 minus 2x2. Okay, so then recall this one here. How can I say this? Bring this 3 to the other side, become negative 3. So 3 minus 3 equal to 0. Negative 2x1 equal to negative 2x2. And they multiply with negative 1 over 2 left and also right. So negative times negative, positive. 2 divided by 2 equal to 1. Negative times negative, positive. So 2 divided by 2 equal to 1. And x1 equal to x2. So fx is a one-to-one function. Okay. Find the domain and range of the function f. Okay. For this one, the function inside, the square root sign here must be always greater than or at least equal to 0. So 3 minus 2x greater than or equal to 0, then negative 2x greater than or equal to negative 3 divided by negative will turn this direction of this from greater than to less than. So x less than equal to negative 3 divided by negative 2 or x less than 3 over 2. Okay. This is 3 over 2. So x less than or equal from here we move to the left side. So that is the dominant function. So the domain of f equal to negative infinity to 3/2, and the range of f, for square root sign, for this one here, the graph will be something like this, from 3/2, and we curve here, something like that. So we refer to the y-axis, is all here to the positive infinity, so come up with 0 to positive infinity. Determine the inverse function of f, and also state the range, domain and range. F inverse, fx equal to square root of 3 minus 2x, turn it into term of y equal to square root of 3 minus 2x. Square here and also here. So then it eliminate between sign of square root sign with the square, then 3 minus 2x equal to y squared. Then negative 2x equal to y squared minus 3, and then divide by negative 2, 2x equal to 3 minus y squared, and x equal to 1/2 times 3 minus y squared. So means that the inverse of this function equal to 1/2 3 minus x squared. Sketch the graph of f and its inverse on the same axis. Now so this is the line of y equal to nx. So now this graph, as I mentioned here, but sketching here now, is from 3/2 and the curve here. Then I'll make adjustment here. So the graph may be something like this. Sorry. Then next, sketch the inverse. Just imagine that if I bring this point of 3/2, the coordinate of 3/2 and 0 here, to this point of 0 and 3/2. So starting point here, there you go. So this is the function of f inverse, and this is the function of f. So that's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh, and I hope you enjoyed it and helps you to recall to solve the rest of the question. So thanks again. Assalamualaikum. Have a nice day. Till we meet again.